Hi, my name is Nicholas Dwork, and today we're going to be discussing K-space. Our discussion starts with two-dimensional waves. Here are 6 examples of two-dimensional waves. Some are vertical, some are diagonal, and some are horizontal. Here's an example of a very slow vertical wave. It's got a peak. There's only really one trough. What I'm going to do is add a bunch of these waves together. On the right-hand side of this black bar is going to be the individual wave that I'm adding, and on the left is going to be the sum of all the waves that I've added so far. So on the right, I'm adding a horizontal wave. It's got 3 peaks and 3 troughs. And on the left is the sum of the vertical wave before with the new horizontal wave. Now we're going to do this a bunch. We're adding different waves of different intensities, and the sum is appearing on the left. Maybe you're starting to realize that an image is emerging from the sum of these waves. More and more details are coming about as we're adding waves of higher and higher frequencies, with more troughs and more peaks. And right around now, you're seeing that this is an image of my old buddy Bake licking the bottom of an ice cream tub. And it turns out this is always the case. Images are always the sums of waves. Each of these waves can be represented by a point in a two-dimensional grid. Here's that grid. So for example, this blue point here on the left corresponds to a vertical wave with low frequencies. Here we've only got maybe 3 troughs. We can move this point up, and that gets us a vertical wave with a higher frequency, more troughs and peaks. And we can move this point over, and now we're getting a diagonal wave. So each point in this grid on the left corresponds to a wave on the right. And there are many more points in the grid on the left than I'm showing here on the right. This grid on the left is called K-space. Now why do I bring this up? Because MRI makes measurements in K-space. Once we make the measurements, we must add all the waves together to make the image. That's the process of image reconstruction. And the function that does that is called the inverse discrete Fourier transform. So here's K-space. The MRI machine will go about collecting one line of data, and then it might go about collecting a second line of data, and then it does that for all the lines. And when you hear the machine make those noises that go something like it's collecting different of these lines. These values are what is stored in the computer. We compute the inverse Fourier transform, and out comes our image. Thank you for your attention.